All right, geometry kids. This video is going to be about angles in circles. Okay? This unit in general is going to be a lot of vocab, a lot of memorization, a lot of formulas. Now, every single one of these formulas could be proven. That could be an entire course in and of itself, quite honestly. So we start with the central angle. We have a circle. A central angle is an angle that is drawn so that its vertex is at the center of the circle. Is an angle whose vertex is the center of the circle. Okay? And whose rays pass through the circumference. Okay? So, a central angle is equal to its intercepted arc. So, what the heck is an intercepted arc? You go to where the rays intersect the circle. This arc is called an intercepted arc. Okay, so a central angle, the measure of a central angle equals the measure of its intercepted arc, and vice versa. Okay, so in other words, here's an easy one. Let's say a central angle is 90 degrees, right? Then its intercepted arc would be 90 degrees, which makes sense because this is 1/4 of the circle, which is 1/4 of 360 degrees. So a 90-degree central angle makes sense that that would be a 90-degree intercepted arc. So that's the way central angles work. Okay, the next thing is an inscribed angle. Sorry about that. Okay, inscribed angle. So an inscribed angle is an angle whose vertex is on the circumference of the circle and whose rays pass through the circumference. Okay, I'm being informal with my through. Okay, so if we think about the previous question, if we think about that 90-degree central angle, right? But now instead I'm going to make an inscribed angle. Okay, this inscribed angle is going to be half the measure of its intercepted arc. So this 90 degrees, that inscribed angle is half of that. And there is a proof for each of these. You could do a proof, all right? I'm not going to be doing all the proofs, but maybe I'll show you one or two in class. All right, so let's think about an angle inscribed in a semicircle. So let's say we have half a circle, and we have an angle inscribed in that. Okay, that's going to be a 90-degree angle, which makes sense because 90 degrees is half of 180. So this is just a fact. An angle inscribed in a semicircle is a right angle. Okay. The next thing is when we have an angle, all right, formed by a tangent and a chord. An angle formed by a tangent and a chord. Okay, I'm sure all of this sounds very foreign to you. So I have some chord. Well, a chord, remember a diameter is a chord, so I'm going to make another chord besides a diameter. So a chord is just a segment whose endpoints are on the circle. Now, a tangent is a segment that touches the circle at one and only one point. So I'm going to have it touch the circle at this point up here, which I will call B. Okay, so a tangent could be a segment, a ray, a line, whichever. A segment, ray, or a line intersecting the circle at only one point. Okay, so when you have an angle formed by these two things, you go from A all the way to B. Let's say this is 100 degrees. Then this angle, it works the same as an inscribed angle. It's going to be half the measure. So a tangent chord angle, is equal to 1/2 the measure of its intercepted arc. Now they could try to do things to confuse you. In other words, they could give you the 260 and ask you for the measure. So you would have to realize, oh, I'm going to subtract 260 from 360. So there are all sorts of unique things they can do. Okay, so then we have an angle formed inside a circle by two chords. Okay, so I'm just going to make two chords. Now, of course, one of those chords could be the diameter. I'm not going to have that be the case here. So if I'm talking about one of these angles, let me say I call this X. This angle is going to be equal to half the sum of these two arcs. Half the sum of these two arcs. So the measure of angle CEB would be 1/2 the measure of arcs CB and AD. Now, when I say arc, I'm talking about the minor arc. When I'm saying the arc from C to B, I'm not talking about going in this direction. Okay, that is a major arc. So when I'm discussing these things, I'm talking about the minor arc. Okay, so just keep that in mind, kids. All right, so the last thing I want to do here that has to do with this is something called a cyclic quadrilateral. Okay, so these are all angles inside the circle. I'll do angles outside the circle in the next video. All right, I don't want to do too much in one video because this material is very abstract. It's not tied into anything that you've learned really. So it's going to seem a lot more difficult than it actually is. Okay, but it's all new material, so it's going to be a lot of memorization. All right. So a cyclic quadrilateral is a quadrilateral that has all of the endpoints on the circumference of the circle. Okay? All right. So let's think about what's going on here. First, let me talk about angle B. So angle B, as you know, is half the measure. So the measure of angle B is 1/2 the measure of arc ADC. Right? Then the measure of angle D, let's do this in a different color. The measure of angle D is 1/2 the measure of arc ABC. All right, so think about the sum of these angles, right? Let's add this together. If we add these up, now the measure of angle B plus the measure of angle D, okay, is going to be half the measure of arc ADC plus the measure of arc ABC. But the measure of these arcs is 360. Because when you put them together, you get a full circle. So you get 180 degrees. So what you're going to need to memorize about this is that in a cyclic quadrilateral, the opposite angles are supplementary. Okay, and I think that's enough for our first video on this unit. So this concludes our first video on angles in a circle. And these angles specifically were inside the circle. Oh, I want to actually mention one other thing. Okay, I always think this is common sense, which isn't the truth. So let's say I said the central angle, all right, is 90 degrees, okay? Obviously, we know what's the inscribed angle then? Half of that. So these are just facts. An inscribed angle is half the measure of a central angle to the same inscribed arc, intercepted arc, sorry. Okay, eventually this is going to be part of our reason bank. All these facts will become part of our reason bank. Okay, the other thing is, let's say I have an angle inscribed to this arc, right? This blue arc. So I have some angle inscribed to this arc. Let me make it green. Well, can't I have another angle inscribed to that arc? In fact, can I have an infinite number of angles inscribed to that arc? So these angles are congruent, okay? So angles inscribed to the same arc are congruent. Okay, last thing I want to mention. Let's say I have an arc. I have an inscribed angle to that arc. No problem. That's no problem, right? Then let's say I have an angle formed by a tangent chord to that arc. Okay, so this angle, as you know, is half of this intercepted arc, right? Now, if I made a chord to this intercepted arc along with a tangent, okay, that angle would have the same measure. So an angle inscribed to the same arc as a tangent chord is congruent. All right. I don't like the way I worded this. I should say, all right, angles inscribed to the same chord as a tangent chord are congruent. Whatever. All right, you get the idea. So those angles are going to be congruent. All right, so that concludes our first video. So just keep in mind, all sorts of things can happen here. All right, and we'll be continuing to work on this during class. All right, thanks, guys.